In this video, we will talk about one lead code problem, that is jump game 2. So let's understand the problem first. We will understand the problem, then we will understand the approaches. We will understand two approach, then we will write the logic and CPP code for these two approaches. At the end, we'll calculate the complexity for these two approaches and we will select the best approach. So let's first understand the problem. We have one array nums and we have to find out how many jump is required to reach at the end point. Here, if it is 2, then it can go to 3 or it can go to 1. From here, it can go to this, and this. Forward 3 position. From if it is 1, then forward 1 position. If it is 1, forward 1 position. If it is 4, if some value is there after this, then you can go to forward 4 position. So like that it is telling. So we have to find out how many jump is required, how many minimum jump is required to reach to the end. Like from here to here, how many minimum jump is required. So this we have to find out. So let's understand the approaches. So let's understand the first approach here. So we have to reach at the end of the array in minimum jump. So this end of the array is our target. So this end index is our target. So what is our index? 0, 1, 2, 3, 4. Total number of element here is 5. So our target is 4. So we can write here that target is equal to 4, which is length of array minus 1. So we have to reach till this target, okay, till this index in a minimum number of jump. Okay, so what we will do, first thing we do in this approach is that we will find out that which index can reach till maximum which index. So here we will update our array like this. So this index 0 can go forward max to max 2, maximum till second index it can go. So I will update this 0 index with value 2. The index 1, whose value is 3, can go maximum till fourth index. So I will update the first index value as 4. The value at index 2, which is 1, can go maximum till 3 index. But already we have went the maximum till 4. So we will compare here what is the maximum value. So value will be there here. So after comparing, we will update here that the max till here it's 4 only. So we'll keep 4. And the value at index number 3 is 1. So it can reach maximum till 4 and our maximum is also 4. The value at index number 4 is 4. It can't go forward, but still will update it as a, and the index value will be 8. 4 plus 4, that is 8. Okay, so this is the first thing which we have done. So this value which we got here is the index value we got. So it is representing here that in one jump we can reach maximum till 2. In second jump we can reach till 4. And what we need to find out is that minimum number of jump required. So minimum of jump required value will be here 2. So this is the first approach. So let's see the first approach code and we will see the complexity of this code also. So this is the first approach code here. And as you can see here in the code that we are going through all the arrays and we are just updating it with the maximum index like we have done here. This thing, this thing we are doing here, maximum of nums I plus I means what we are doing here. As you can see that 3 plus 1, so this 3 plus 1 and already which is the maximum. So from here till here, what is the maximum? It is telling maximum updating here in the nums of I. And at the end, what we are trying to find out is that where this thing and the second thing we have to find out the minimum number of jump which is required. So here this answer, this is the jump. So first of all we are checking what is the at first position. So at first position we got the value. Now again our value which we got is less than our target. So we again went there, then again we got the 4, and 4 is not less than our target value. So that's why our answer will be 2 here. So this is the logic of the first approach. Now let's understand the second approach. So in the second approach, we will just see this. So here, if you will see, then this value is 2, means it is having two way. First way is to reach to the first index. Second way is to reach to the second index. Here also this, if it is going to the first index, then from here it is having the three possibilities. It can go here, it can go here, it can go here. And from here it is reaching to the last position. So if 2 from here, if we are going on the first jump, then we are going to the 3, and from 3 we are reaching from 3 we are taking one more jump here, that is second jump, then we are reaching to the end. So he so let's build the logic for this functionality. So let's I will show you the code of mine. So here what I am doing is that in the code you can see here is that I am just assuming one while loop. In the while loop I am telling that if maximum reach is less than target, and our target will be always the last index. So here you can see the target value I have set, that is length minus 1, which is the last index. So what I am doing here is that if max reach is less than target, means here its max reach is what? Its max reach is still only the second position, which is still less than that our target index. So here I'm giving this logic: if max reach is less than target, then for int I is equal to left, from till I is equal to less than or is equal to right. So what is left and right here? So here its reach is starting from this 3 and ending at this 1. So this 3, this index is the left one and this ending one is the right one. What I'm doing here is that giving a maximum reach is equal to nums I plus I, means if it is here, then 3 plus 1 is 4. So its maximum reach is 4 now, or its maximum reach is what? 1 plus 2, 3. So 4, between 4 and 3, which one is maximum? So 4 is maximum. So that 4 I am putting here. And if maximum reach is meeting out a target, then I am ending the for loop and I am just incrementing the jump value and returning the jump. So this is my logic. So this logic is beating up to 100%, and our the previous logic was beating up to 100% also. So let's see the complexity of both the logic. So if you will see the first approach, then the first approach what we are doing here, we are using two loop. One is for loop and one it is while loop. And this is going n time, this is going n time. So run complexity will be n plus n, that is 2n, that is n. So our first approach, the runtime complexity is n. Approach, what we are doing is that we are using one for loop inside the while loop. We are using one for loop inside the while loop. So this for loop will run n time, and this while loop will run n time, and this for loop will run n time, that is n ka power 2. So its complexity will be n ka power 2. So I think our first solution is the good solution, and hope you understood this video. Thanks for watching it.